Hi everybody, welcome to the Java course. This video is going to discuss the mechanism of variable assignment. So the variable assignment is actually following this approach. Okay, first we need to declare the primitive data type, and then we give the variable name, and we provide an equal sign which means assignment, and the value to be assigned to the variable name is called the literal, which is put on the right hand side of the equal sign, and then we will end the whole statement with a semicolon. So for now we take integer primitive as an example. We have some ways to put a literal onto a variable. One way is like this. I just use one line to do the integer assignment. Here the data type is the integer primitive, and the variable name is int3, and the literal is simply an integer value of 3. And the equal sign means that I'm going to put the numerical value number 3 to the variable whose name is int3. So this is my notation to indicate the variable content. int3 means that I'm putting an integer value of 3 into the variable with this name. In addition to using one line, we can declare 2 or even more primitives on one line. The idea is like this. On this line, I declare 2 primitives, all of which are integers. So int4 is the variable name that is going to store an integer value of 4. And integer 5, int5 here, is the variable which stores an integer value of 5. So the declaration of 2 integer primitives is separated by a comma. Of course, at the end of the whole assignment statement, I have to end the line with a semicolon, which is similar to what we did for the first situation of just having one variable to be declared. Also, we can use 2 lines. How can we do that? On this line, I just provide the variable name, but I didn't put the literal onto the variable yet. I can do it on the second line. Okay, the second line is doing the real assignment. I put an integer value of 9 to the variable whose name is int9. So there are many ways to help us define the primitives. So let me try to print out the primitives. I can print out a value of this integer variable, and at the same time I can do something similar to another integer primitive. Save it, run it. Okay, I got 3 and 4 printed because 3 and 4 are actually the values stored in the 2 corresponding variables. We have to notice that when we give the variable names, we have to follow some basic guidelines. Actually, we can only use alphanumeric characters together with the sign like this, that is a horizontal bar at the bottom. So we can only use alphanumeric characters together with this character. And we have to notice that we cannot start a variable name with numbers. So this is not allowed. If we want to set up a variable name like this, this is not allowed. Why? Because a variable name cannot start with numbers. But for the previous variable names, they all start with a character, so it is allowed. And when we declare variable names, we have to notice that Java is case sensitive. What does it mean by that? We really care about the capital letters and small letters. We will treat the names differently. When we have two variable names like this, there are two distinct variables, even though one variable name is simply the lowercase version of the first one. So we have to notice that Java is case sensitive. That means the capital letters and small letters are not interchangeable, especially on the variable name. Next, we will talk about the arithmetics of the variables. So how can we operate on the variables? We can have some examples to show you. If I want to find out the product of some numbers, I can do something like this. Okay, here I'm going to print out the product of the four numbers, and the result will become part of a string to be printed out. So I can use a pair of round brackets to surround the values to be operated. So I'm going to find out the product of 3, 4, 5, and 9, all of which are integers. And I can use a plus sign to join the answer together with other parts of a string. So let me see the result. Save it, run it. Okay, the product is 540, which is obtained by multiplying 3 and 4 and 5 and 9. So we can make use of parentheses to surround the numbers to be operated, and then we can join the answer to other strings by using the plus sign. We can notice that if we want to break a line, we can simply click enter to do so, so that the whole string will become just one continuous line shown on the console. Okay, we can have other types of operations. Okay, this one is already clear enough according to the logic mentioned above. Save it, run it. I will get a -2 because this is the result of 8 minus 10. Okay, let me show you something quite special in coding. I'm going to add 1 to the variable called value, and then I'm going to assign the new value to the original variable called value. So the original value is 10. After adding 1 to the original value, the right hand side would become 11, which becomes the literal for the assignment statement. And then the value of 11 will be put into the original variable name called value. So the variable called value is being replaced by 11 instead of using the initial value of 10. This is allowed in computer science and in programming. Although it is not sensible to do so in mathematics, we can do something like this in computer programming. The reason is that we are doing assignment by putting the things on the right hand side of the equal sign to the variable name shown on the left hand side of the equal sign. We are not doing equality here, we are doing assignment. This is the fundamental difference between coding and mathematics. So we can say that the variable called value would become 11. How can I prove that? I can simply print it out. So I'm going to print the value together with string, so I can join these two parts with a plus sign. Let me see the result. Save it, run it. Okay, the value becomes 11, which is quite sensible according to the assignment statement mechanism. Okay, we can do something new here. When we see this operator plus equals, it is simply meaning something like this. I do the addition of value to 2, and then I assign the new literal to the variable. So value is initially 11. After doing this operation, value would become 13. Let us see the result by printing it out. Save it, run it. Yes, the second line would give me 13 as the result of the addition shown on line number 27. We can do similar things with subtraction, multiplication, and division. This statement is equivalent to this one. I subtract 5 from value, and then I assign the new literal to the original variable. So let's see the result. Save it, run it. Yes, the value becomes 8 because it is obtained by subtracting 5 from 13. And then we can do similar things for multiplication. So we can expect that the value would become 24. Let us see the result. Yes, it becomes 24 because it is obtained by multiplying 8 by 3. If I do the same for division, I will get the answer to become 8 again. Yes, that's the result. Here, 24 divided by 3 would become 8. So I will get 8 as an integer value. So it is quite sensible to notice the simplified form of the assignment statements shown on these 4 lines. When we are able to use these operators, the code will be made a bit more simplified. When we do calculations, we have to notice that the order of operation is multiplication and division followed by addition and subtraction. This is something quite fundamental in mathematical calculations, and this applies also to Java computation. So let us see an example to see the effects of this rule. What will we expect to get? According to the rule shown above, we have to handle the multiplication first, which would give me 20, and 3 plus 20 would become 23. So we will expect to have 23 as the printing result. So let me see the result. First, I have to comment out the previous printing statement. Save it, run it. Yes, the answer is 23 because I have to do the multiplication first according to the rule shown above. If we really want to find out the sum first, we have to make use of the parentheses. So I can do something like this in order to handle the addition first. For this situation, I will get 35, which is the result of 7 times 5. Yes, the answer is 35. So it means that I'm doing the addition first, and then I will do the multiplication. And the addition is done first because I put parentheses to surround the operation of addition. So we have to handle the things inside the parentheses first, and then we will do the rest of the operation. If you are new to Java, one thing about division is quite tricky to you. This is called integer division. What does it mean by that? We can see some examples to illustrate the effects of integer division. Let me show you an example of direct computation. For mathematics, 9 divided by 4 would be equal to 2.25. But when we use one forward slash to do the division, we will do the result as only 2 because we don't handle the decimal places when we do the division of 2 integers. So integer 9 divided by integer 4 would be simply equal to the truncated part of the ordinary division result. Let me see the result by printing it out. Save it, run it. Okay, the answer is 2, but not 2.25. So when we do integer division, we will simply have the integer part to be shown, and the decimal parts are all ignored. And of course, the value coming from the integer division is also an integer. So we have an integer 2 as the answer. And we can have another way of doing integer division. Okay, since we already know that the integer division result would give me an integer, I can decompose the print action into 2 parts. First, I create a variable to store the result coming from integer division, and because I know that integer division would give me another integer, I use int as the integer primitive type to declare the variable that stores the integer division result. And then I can print the value of int2. So let me see the result of the 2-step approach. Okay, I will still get 2 as the answer. And we have to notice that we really need to declare int2 as an integer primitive, because this is the data type coming from integer division. In addition to integer division, we can find out the remainder of the division of 2 integers. Of course, we also have 2 ways to do the remainder calculation. The first one is direct computation. Okay, this percentage sign means modulus. That means I'm going to find out the remainder of 9 divided by 4, which is equal to 1. So let me see the result by printing it out. Save it, run it. Yes, the answer is 1, because 9 divided by 4 would be having a quotient of 2 and remainder 1. Of course, we can do similar things to decompose the printing action into 2 parts. And of course, we have to use integer primitive to store the result coming from the remainder operator. Okay, Since we will know that the result will be an integer, we have to use integer primitive data type as the variable type of int1. Of course, I can do the print action. Let me run it. Yes, I will still get 1 as the answer, which is the remainder of 9 divided by 4, both of which are integers. And something to notice is that when we do integer division, we have to take more care than doing other mathematical operations. The reason is that there can be some tricky situations. What will we get as the output of this printing statement? First, we have to handle the divisions first. We have 2 divisions here. The first one is an integer division, so we will get 4. And the second integer division will also give us 4. And 4 plus 4 would become 8. So the answer would be 8. Let me check by printing it out. Yes, the answer is 8. So we have to realize the meaning of integer division to avoid the conclusion that we will get 4.5 plus 4.5, which is equal to 9. When we do integer division, we have to make sure that you know what you are doing. We will get 4 here and 4 there. So we won't get 4.5 here and 4.5 there. And this is something we have to remember when we apply integer division. After we have discussed integer primitives, we can talk about double primitives. So how can we assign double values? We can have some similar approach. Okay, I can use the double keyword to denote that the 2 variable names are going to store some double values. And my notation is that P means decimal point. So I'm going to store 53.0 to the variable name shown here. And I'm going to store 2.0 to the variable shown here. Even though we are going to store some values without decimal places practically, we still need to add 0.0 as part of the value to be stored in double variable type. Why do we need to do so? Because we add 0.0 to make the literal become a floating point number. If we ignore this 0.0, the literal will simply become an integer, and an integer should not be put into a double variable type. Otherwise, it is possible that you will make some confusion. Let me save it and run it to see the effect. Yes, we can see that it is not allowed to do so. And the reason is that and I can also print it out to see the effect. Let me save it and then run it. Yes, it is still allowed, but it would make the presentation a bit confusing. We should actually assign a double literal to a double variable type. Even though it is allowed, we should avoid doing so. And then we can take care of the division of the double variables. Let me see the result of division of two double values. Since we are doing division of two double values, it is quite natural to expect that we will get a 26.5 as the answer. Let me see the result. Yes, the answer is 26.5. So if both the dividend and the divisor are double values, we can treat the division as ordinary mathematical operations. We don't have to consider the problem with integer division. So we will simply do division as normal as when we do mathematics. And then we can also do the print action by using two lines. The first one is declaring a new variable to store the answer of the division. Okay, because we know that the result will be a floating point number, I need to use a variable of double type to store the answer coming from the division on the right hand side, which becomes the literal of the variable assignment to the variable called double 26p5. And then I can print it out. Okay, the answer is 26.5 because this variable is storing a double value. I have to use double as the variable type. The final point to note when we assign variables is the use of the final keyword to make a variable a constant value. So what does it mean by that? We can use the final keyword. If I want to make sure that a certain variable will no longer be able to change its value, I can use the final keyword before the primitive type. And for constants, it is customary for programmers to use all capital letters as the variable names. So what does it mean by having a constant? When I want to change the value of a constant to another value, we can see that the IDE doesn't allow me to do so. It will give me an error when I want to really run it. Save it, run it. Yes, there is an error because after setting this variable to be a constant, I can have no chance to change its value. So what's the purpose of using a constant? If we want something to become unchanged by accident, we can make the variable a constant. So how can we make use of the constant? I can show you an example. I can use the constant to do some further calculations. So we will expect that the printing action would give me 568. Let me see the result by saving it and running it. Yes, the answer is 568, which is our expected result. So when we have a constant, we can have no chance to change its value by assigning a new literal to the original constant variable. But we can make use of the constant variable for our further calculations. This is the end of the video. If you have any questions about my video, feel free to leave your comments on the comment section below the video. If you like this video, please give me a like and please subscribe to my channel. Thank you for watching.